Hey guys, welcome back. So this is another video on nodal analysis. As we have discussed the entire concept of nodal analysis in the previous lecture, I brought you some more examples based on nodal analysis. So this is one of the example of nodal analysis. So for this example, all you need to find out is node equation. All right. So without wasting any time, let's get started. And for the viewers who are watching this video for the first time, who are watching this video without watching the previous lecture, I want you to watch the previous lecture for you to get a better idea. All right, it would be better if you follow the complete playlist for the detailed explanation. For your proper understanding. All right, we have come across topic by topic in the entire series. All right, so without wasting any time, let's get started. So you know the standard procedure for solving any network or circuit by using nodal analysis. There is a three-step standard procedure. One is selecting a reference node, and always my reference node will be ground, that is 0 volts. And the second step is assigning voltages for other remaining principal nodes, right? So in this in this example, I have only two principal nodes. See, this is one of the principal node and this is the other principal node, right? So you know the meaning of principal node, and in this for this example, I just have two principal nodes, and I've considered this as my reference node, and the other principal node, the other principal node that is remaining is only this principal node, right? So I'll assign some value to this one. So let us say this as V. And the third step is your node equation. That is what we are here to do, right? Before that, I need to assume. So it is very simple. You can try it on your own. You can pause the video and try it on your own. And for the new viewers, for those who are watching this video without watching the previous lecture, I'll explain you. We need to assume some things before writing a node equation. So that assumption is my voltage, my VP is greater than any other voltage in this network and this circuit. All right, so that is the thing we need to assume. Your VP should be, let us assume that this VP is greater than any other voltage in this set circuit. All right, so what are the voltages in the circuit you have? One is V2, the other is V1, and the third is 0 volts, right? So this VP is greater than V1, and VP is greater than V2, and VP is greater than 0. That is what we are assuming here. All right, and now node equation nothing but a KCL plus Ohm's law, right? Node equation is KCL plus Ohm's law. All right, so this is I1, I2, I3. So what is KCL? Algebraic sum of currents at a node is equals to 0. All right, so this is I1 plus this is I2 plus this is I3. This is your is equals to 0. This is your KCL, right? So what is I1? According to me, it is current flowing through R1 resistor is called I1, right? So what is current flowing through R1? According to Ohm's law, I is equals to V by R, right? So always current flows from higher potential to lower potential. And which is at higher potential here? It is VP, right? Because VP is greater than V1, as we have assumed. So VP is greater than V1. So VP minus V1 by R1 will be your I1. In the same way, VP minus V2 by R2 will be your VP minus of, but see here it is minus V2. The direction, what do you call this? Terminals are different here. See, it is plus minus and it is minus plus. It is nothing but minus V2 in this direction. All right. So VP minus of minus V2 by R2, that is my I2, and VP minus 0 volts by R3 it is. All right, so this is nothing but the node equation for this circuit. This is how you calculate node equation. For the better idea, you just please follow the previous lecture. All right, so here I have another example. As we know the three-step standard procedure. The first step is taking a reference node, and this will be my reference node. All right, so as I've already said, in nodal analysis, the number of node equations will be n minus 1, right? Where n is your number of principal nodes. All right, so your number of node equations in nodal analysis will be n minus 1, where n is your number of principal nodes. Alright, so just see how many number of principal nodes are there here. So this is one principal node, this is other principal node, and this is other principal node. What do you mean by principal node? Principal node is intersection of two or more branches, right? So see here, three branches are intersecting here, three branches are intersecting here, and 1, 2, 3, 4. 4 branches are intersecting here. All right. So there are three principal nodes here. So 3 minus 1, on the whole you'll have two node equations here. So for the circuit you'll have two node equations. All right. So let us try to find out what are those node equations. All right. So when considering node 1, when considering this node 1, we must consider that Vx is greater than any other voltage. And when considering node 2, we must assume, or we must consider, that Vy is greater than any other voltage. All right. So as mentioned in the 3-step standard procedure, what is your second step? You must assign voltages to remaining principal nodes, right? So I have assigned Vx to this principal node and Vy to this principal node. And when we are considering this node 1, we must consider that Vx is greater than any other voltage in this circuit. I mean, see, Vx is greater than V1, Vx is greater than Vy, Vx is greater than V2, and Vx is greater than 0. Alright. So what will be my node equation? Vx minus V1 by R1. You just please watch previous videos for better idea if you did not watch. And Vx minus 0 by R2. Vx minus 0 by R2 plus Vx minus Vy by R3. Vx minus Vy by R3 is equals to 0 is your first node equation. And the second node equation is, while calculating the second node equation, I mean while writing the second node equation, you must consider that Vy is greater than any other voltage in this circuit, right? So Vy minus Vx by R3. Vy minus 0 by R4. And Vy minus V2 by R5. Minus V2 by R5 is equals to 0. This is your equation number 1. This is your equation number 2. And when you solve equation 1 and 2, you'll get Vx and Vy. Alright. So this is one of the example based on nodal analysis. And in the coming example, in the next example, we'll see a special case which is called super node. And we'll also see a method to overcome this super node. How can we solve a network when this condition called super node arises? All right. So this is all for this lecture. Thank you so very much for watching this video. And please do not hesitate to share the knowledge. And you know one thing, I've been taught this subject from a very good teacher. He really explained me very well. And I want you to get this content for free. So that is the reason I'm making this video with lots and lots of effort, with the very minimum facilities I have. So please do not hesitate to share the knowledge and help me reach out as many students as possible. Share with your friends and help them do better in this subject, help them clear their exams. All right. I'll definitely try to complete this entire network series. Every topic in this, I'll not leave a single topic. So thank you so very much once again. Bye-bye. Good time to you.